Hi friends, this is Miloš. I've got a lot of questions from you on how you can map deforestation data, and in this tutorial I will show you how you can easily do that. Alright guys, our first step is to install and then load the packages that we need. The first two we will actually install from GitHub, and in order to install from GitHub you need to have a remotes package, so you can use this install packages remotes to do that. After that we can just call remotes, and then from remotes a function which is called install GitHub, as you can find here. And then after that, you just need to provide the link to the repo. And this is actually the name of the repo. So this is first of all going to install rgeoboundaries, which is a library for national and subnational boundaries. Because we're going to be taking the subnational boundaries of Spain, specifically Galicia, we will need this package. Now, the second package that we need relates to background maps or layer maps. And again, we can use here remotes, install GitHub as we did in the previous step. And after that, we can simply here type the link to this repo. This is going to install maptiles package, which allows you for fetching background maps from maptiles API. All right, now we can go ahead and install and then load the remaining packages. We will do that using pacman package. Again, if you don't have this package, you can install this package using install packages from base R and just write here pacman. Once you install pacman, I already have it, you can just call it. And then there is a function within pacman which is called pload. This is going to install and load the packages that we need. We already installed some of them, so we are fine. And we can just load them. For example, one of them is rgeoboundaries. Again, this one is used for fetching polygons for subnational units or country units. The second one that we'll be using is Terra package. We're working with raster files since we'll be working with deforestation, and deforestation is packed in raster files. The third one is SF package, which is used for dealing with polygons. And then we can also call the one that we previously installed, which is called maptiles, for getting, of course, these background maps. Then we will definitely need tidyverse here, because tidyverse is an umbrella package that has data wrangling and data visualization packages within it. And one of them we'll need is ggplot2 for mapping, for creating our map. And then last but not least, we will also utilize tidyterra package for mapping raster files as they are without turning them into a data frame. In today's tutorial, we'll be mapping deforestation of Galicia in the last 20 years. So we first of all need to fetch the polygon for Galicia. We'll be using rgeoboundaries, which we previously installed and then loaded. And we're going to create here an object called region SF. Then we're going to be calling rgeoboundaries. And then we're going to be calling specific function here, which is called gbadm1. This is for fetching level 1 administrative boundary. So this is the next subnational level below the country level, the highest level. And this is going to allow us to get the boundaries of Galicia. This is how you can get for any other country their respective region. But before you do that, you first of all need to specify your country of interest using ISO 3 code for that country. So in our case, the ISO 3 code for Spain is ESP. All right, so actually once you run this, you can then quickly inspect what we got here. So what are the fields by just opening this one. And then what you will notice is that we have actually 19 features here. So there are 19 this level 1 administrative units of Spain. And these are some of them that are shown here. One of them, as you can see, under shape name here is Galicia. So what we just need to do is simply, get this name. Sometimes maybe you don't know really the complete name, or maybe your complete name is not correct. Like, for example, in this case of Melilla and Ceuta, you have also this additional part. So I'm going to show you how you can simply grab the name itself. All right, let's go back here and let's actually add to this a pipe. And then let's filter out using this, of course, shape file name, or shape name to be more precise. So we can use grepl, which is for grabbing, again, grabbing part of the string. And what we want to do is we want to grab the string which contains this Galicia. All right, and then we want to get this from this shape name column. You can also quickly check whether you really fetched the subnational boundaries you wanted by using the plots from base R and then plotting just the base or the geometry field from this region as F. Once you run that line, you should be able to see the boundaries of Galicia. We will fetch the data on deforestation from global land cover analysis and discovery, or just GLAD. And we can just simply type this in our search and then go for actually the first here result that we got, which is then going to open up Google Earth Engine, where you can actually see this data in an interactive mode on an interactive map. And you can also check here what they actually have. So what they actually have is the tree cover, the percentage from 2000, which is the base year. And then for every year after 2000, they also have whether there was a loss or whether there was a gain in trees. In other words, deforestation or reforestation. In today's tutorial, I will just show you how you can analyze and how you can map deforestation, but you can apply this same method also to reforestation if you're interested. So in order to access the data, you need to click here on this download the data link, which is going to take you to the main page from which you can fetch the data. Now over here, you can find some very useful information about this data set. If you want to go into detail about that, you can also check in different updates as well. But if you just want to head to the data sets and the variables, you can go to the data set details part, which is going to tell you that this data is organized in 10 by 10 degree tiles, which is approximately 30 meters per pixel at the equator. And there are several files here. So we're interested in, first of all, the first one, which is called tree canopy cover for the year 2000. And the name of this variable is tree cover 2000. So this is the percentage or fractional percentage cover of the land that denotes what is the share of the trees on each pixel. So it ranges from 1 to 100 or from 0 to 100. So that's very useful for us. Then you have gain. So basically this is reforestation. And then you have lost year, the name of the variable, which is deforestation. This is exactly what we need. So this one, very importantly, you can find here in this short codebook, is organized in such a way that it has values from 0 to 23 in this case. So 0, it means no loss, and every other number represents the year of observation for which there was a loss. So 1 corresponds to 2001, 2 corresponds to 2002, and all the way up to the last number, which corresponds to the respective last year. Okay, so in this case, we actually need this tree cover 2000 and we need lost year. Of course, we're not going to download the entire data set because it's quite huge. What we need to do is actually fetch the appropriate tile that we need. Now, this is a bit tricky because you actually need to know where a region of interest is located. We know that in our case, this is the one. So the one that goes from 40 to 50 north and from 0 to 10 west. So if you click on this one, then immediately all these links will change to this appropriate tile that you selected. Now, in this case, what is very useful for us is that this link is almost the same for all of these types of data sets, except for the variable name. And this is going to help us actually easily load into R both the tree cover 2000 and the loss year data set. So we just need actually one of these links, and then we can replace them in R with the variable name, being two variable names, tree cover 2000 and loss year. So what we can do is we can simply right click on this first one, which is for the tree cover, and we can just select copy link address. Once we have that, we can just head back to R, and then we can start loading this data into R. Back in R, I pasted this very long link, but as I said before, we can use it to load or to download both the data sets that we need. Here's what we're going to do. Well, first of all, we're going to define the variables of interest. And as you remember, we actually have two variables of interest. One of them is already here in this one. It's called tree cover 2000. And this one signifies what was the percentage of the fractional cover under the trees in 2000. So this is going to be our baseline for tree covers. The second one, if you remember, is called loss year. And once we actually define this, we can then go ahead and create two URLs out of this. So I'm just going to call this new list URLs. And then what I'm going to do is I'm going to first select this link up until the point where the name of the variable starts. So until here. I'm going to then copy that. Then I'm going to back here to URLs. Then I'm going to turn this into a string. And then I'm going to add here comma, because why? I'm going to then add the variable, all right? And then I'm going to then type comma again, and then I'm going to add the remaining part of this, which is here. And this, again, I'm going to put under double quotation marks, creating the string. This was possible because this URL is the same for each variable except for this variable name. So what I'm going to do next is actually, I'm going to simply, delete this link, and then I'm just going to create this. All right, I'm going to create. Now, for creation of this one, you actually here, instead of this C, you need to paste 0, because this is essentially going to glue together this main link variable and this remaining link. So then if you actually inspect these URLs list that we found here, you will see actually that we created 2 links that look almost the same except for their respective variables. So the first one is tree cover for 2000 and the other one is the deforestation for the same tile. Now we can use this list of URLs and fetch both of those tiles into R. So I'm going to create forest data object, and because here we want to deal with 2 raster files, we want to put them into a list. Now, in order to put them into a list, we need to use lapply, which means you want to apply a certain function onto a certain list. In our case, the list is called URLs, and the function we want to apply is a rast function from Terra. Rast function from Terra is used for loading raster files into R with the help of Terra package. And if you inspect this forest data list, you will find 2 raster files with the same dimension, resolution, and extent, but these are different types. The first element of this list is actually the tree cover for 2000, as you can see from the name of this tile. And the second one is the deforestation for the same area. Okay, so we got the data, but we do need only the extent of Galicia. So what we're going to do next is we're going to crop both data sets, so both the forest cover and the deforestation one. Now, in order to do that, again, we need to apply the crop function from Terra onto this list of raster objects. So I'm going to create forest region object. And then what I'm going to do next is, again, use this lapply because we're applying to list. The list is forest data that we just created. And then we're going to create a function here, which is going to take element x. And then within this function, we're going to be using Terra crop from Terra. So Terra crop, what it does is it takes a raster file or raster files and then crops them by the extent that we choose. So what we're going to do here is we're going to take this x, and then as base layer, we're going to be taking, of course, this region asset. Now, what this is going to do is this is going to create the extent, so not just the borders, but also around the borders of Galicia. And then again, you can quickly inspect if you really got what you wanted. And this time, using plot function from Terra, we'll be plotting the first element of this forest region list, which is basically the tree cover data. At the end, you should be able to see the tree forest cover for Galicia as presented here on this map. Mapping the deforestation values for each of the 23 years would be very messy. Instead, in this tutorial, I will show you how you can condense this information and show the overall deforestation in the last 23 years, as well as the deforestation for certain periods. And for that, we will need to reclassify our raster file. In our first attempt, what we will do is we will reclassify these 23 different values into a single value showing deforestation. And for that, we will first of all need to define the breaks. So our breaks will consist actually of 2 values or 2 breaks. The first one will go from 0 to 1, meaning this is going to capture all those values that have not experienced deforestation. And then the second break will go from 1 to 23, not to 2023, so just 23. And this one will show you the deforestation, the overall deforestation in this period. Okay, so that's the first thing. Then the second thing that we want to do here is, apart from creating here object, which is going to be denoting this one, we want to, as we said, reclassify this raster file, which now has 24 values, so 0 and 1 to 23. To do that, we will be using classify function from Terra, and then over here we'll be passing this forest region file, and we will be passing actually the second element from this one, which covers actually tree cover loss. And then in the second part, we will be just defining the breaks that we will be using here. Now, this is going to produce a raster file with continuous values, but we want categorical values. So in order to have those, we simply need to turn this one into a factor using as factor from base R. Then again, you can simply inspect if we really got the two values. And you can, again, call plot from Terra package and simply pass here this newly created one, which is forest loss region. As you can see, this shows exactly two categories in our reclassified raster file. And unfortunately, the one showing deforestation 1 is very much present on this map. All right, in this part, we're going to go ahead and turn our forest cover raster into an RGB raster plot, as we did in one of the previous tutorials. The reason why we are doing that and not keeping it as a raster is that ggplot2 can accept only one raster and then have the color values for it. So essentially what we're doing here, we're assigning to this one colors here, and then this is going to be immediately plotted then using ggplot2 without the need to specify customized colors. So you remember that the forest cover has actually percentage, so it goes from 0 to 100. So these are continuous values. What we're going to do is we're just going to, for all the values that are above 0, we're going to just recode them as 1, and everything that is 0 is just going to stay 0. So we're just going to have two values, whether there is a forest or not, using this rough cutoff. To do that, we can use Terra if-else, which is basically an if-else function just for raster files. And over here, we're going to take forest region. And as you remember, the first one, the first member of this list is forest cover. So if it's greater than 0, then we're going to turn it into 1. And then otherwise, we're just going to turn it into missing values. The reason why we're turning into missing and not into 0 is that we want actually all the values that are that there is no forest, we want them to be visible. And that's going to be a background layer map, which I'm going to show you in the next step. All right, that's the first step. The second step is that we want to assign color values to this one. So actually over here, what we need to do then, we first need to create a set of color values in hex code that we want to use then to assign to this raster file. So I went actually for olive green, and I to represent the forest cover, and I went for a red color to represent the deforestation or a forest loss. So this is going to be the first one. So this is going to be the olive green color. And then the second one that I chose is a very light red color. The reason why I chose this olive green, of course, because it denotes trees, but also moreover because the layer background I'm going to be using is a very light version of this one, which actually goes more towards beige. So I think this is a good complementary color, but this one actually stands out as the contrasting color to the forest. Now with that, we have these two. What we're actually going to do for the forest cover itself, we just need this first value of this palette. So we're just going to create a new object here, calls. The reason why I'm keeping here both is that I'm going to use them afterwards in ggplot2 to assign this one to forest loss, which we already created. So over here, I'm just going to take the first palette from this, or first color from this list. And then we need to actually assign these values, again, something that we did before. So we need to put from two values. So this one goes from 1, and that's the only value. And then 2. And over here, we want to assign this specific color. So to do that, we need to actually transpose, and then we need to turn color to RGB, because this Terra function works with that. And then we're going to enter this hex value. All right, once we actually do that, then the very last step is simply to get rid of any NA values that exist in this forest cover region that we previously created. So I'm just going to type it here. All right, we're going to come here and then we're just going to put NA omit. So we're just going to discard everything that was turned into NA, meaning everything that has no forest cover at all. And then in the last step, what we're going to do is we're finally using all these values that we previously defined. We're now going to substitute these values using subst function from Terra. So over here, we need to pass, first of all, this forest cover region. That's the first part. Then the second is argument from. So in our case, it goes from 1 and ends with 1. That's the only value. 2 is of course, colors that we want. And then the names of this object are going to be then the colors. So we essentially turn this into an image. And what we want to do now is also inspect what we got. To do that, you can again call Terra, but this time instead of using plot, you will be using plot RGB because our raster has RGB values, so red, green, and blue. And then over here, you can just paste this one and then run this. In a few seconds, you should be able to see then this new raster file. You can see that the forest here is denoted with this olive green and the lack of forest is denoted with white. To provide a bit of a context to our map, we can also add a background, a layer. And we can do that using map tiles package. The first thing, however, that we need to do is we need to provide the extent of our map. And for that purpose, we'll simply create here a bounding box using SF package and then paste here the region SF object. Then we can go ahead and use map tiles just as we did in some of the previous tutorials. And a function called getTiles will allow us to do that. Now, in this one, we first of all want to provide the bounding box, which we previously defined. Then we want to choose a provider. So providers here, there are many of them, as you can see. So there are a bunch of them: OpenStreetMap, Stamen, S3, CartoDB, ThunderForest. So I use a lot CartoDB in the past. And this time I want to actually use S3 Nat Geo World, so Natural Geo World map, because it's quite green and lush. It looks amazing. It has also labels. It also has rows. They're not going to be completely visible because the Galicia as a region has a lot of forest, but it also has lost a lot of forest cover in the past 23 years. Anyways, I'm going to be using this one. If you really are interested in seeing how they look like, you can either check them out here and map them, or you can simply go and search for the map tiles GitHub page, and over there you can also see how all of them look like. For the zoom level, I'm going to go for a bit higher zoom with a bit more level of detail. So for example 10. You can also go for example 9 if you want to have actually more details, but it's going to be a smaller image. Then what I'm going to do is, of course, just crop for the area that I need, and then I'm not going to reproject. I'm going to be using here this one, which is pseudo Mercator 3857, and that's something to keep in mind. That's something that we need to reproject too. So before we actually do that, we can then also inspect. This one is again image, so we need to use from Terra plot RGB and then simply paste this one here and then run the code. And then you should be able to see the background layer map of Galicia with the nature topography, roads, but also city and region names. Before we dive into data visualization, one thing that would be also very interesting to find is how much of the forest cover area has Galicia lost in these last 23 years, and how much of the cover area it actually had back in 2000. Now, to do that, you first need to actually calculate the size of every cell size. So, for example, if we're going to go for the one that shows forest cover, we need to use a function which is called cell size from Terra. And this is for every cell, it's going to calculate how much of the size it is. All right, so for the forest, we need to use forest cover region. So remember, this is the one before we turned it into only one value. So this is the one that has fractional percentage cover. And then over here, you can choose your unit, and I'm going to go just for hectares. I think here you can choose several ones. You can choose square meters. You can choose, I think, also square kilometers, you can also choose hectares, but I think hectares are more predominant unit of measure when it comes to forestry. The second thing, once you actually have this, you can then do zonal statistics, and we can just do that using Terra zonal. And then over here, what we need to do is cell areas forest. So that's going to be our first one. Then we want to calculate this over, again, forest cover region. And then the last one is the function we want to use. We want to sum up all the values over this area. Once you inspect this newly created file, it's going to have actually only two columns. The first one is going to be the value for which you want to see the size, and the other one will be called area, and this is going to be the size in hectares. So you can see that Galicia back in 2000 had 2.2 million hectares of forest area. You can then go ahead and, using the same method, also calculate what is the size of the area that was deforested. So you can essentially go ahead, copy this, and then just paste below, and then simply change here the names, of course, and because over here what we're interested in forest loss, so simply change cover for loss. And then over here what we're gonna have then is, we can also change this one, and then also forest loss regional. And then once we actually inspect this one over here, you will see that the area size that was lost in the last 23 years is astonishing, almost 800,000 hectares. So more than a third definitely of the forest cover was lost in the last 23 years. That is insane. So you can even check, how much this is. So you can just go ahead and calculate that. But that's a very, very astonishing number. You can then also, in the next step, once we create the data visualization, also report this number if you wish. All right, and we can finally make our map as well. Before we do that, I do want to reproject everything to the coordinates reference system that layer background map is using. So as we said before, that is the pseudo Mercator 3857. That's the one. So I will be reprojecting also other raster files. Now let's start adding the layers. So when you're working with ggplot2, one thing to keep in mind is that it essentially, ggplot2, what it does is it works with layers. So you build the layers, and with the first one that you put everything else on top of that one. And that is something to keep in mind, because the base layer will actually be covered with some additional information. So in our case, what we want to do is we first want to put the layer map, the background map, and then we want to put on top of it everything else. For that, we'll be using tidyterra. It comes very much in handy because it helps us actually plot these essentially image files. Raster state turns into image files. Over here, again, we're going to be starting with this background map. And then what is actually pretty cool is that you can also set the number of cells that your map is going to have. So this is how crisp your image resolution is going to be. Over here, what we're going to do, using nCell function from Terra, we're just going to be using the number of cells from this BG map as our foundation. And then what I'm going to do, since this is the first layer, I'm going to give it complete opacity so we can completely see this first layer. Now, on top of this layer, what I want to put next, I'm not going to put actually forest loss. I actually want to put forest cover, because since some of the forest cover for 2000 was lost, I want the forest loss to come at the end and actually go over that forest cover layer. So again, we'll be using tidyterra. Now, this one is going to be the same function, because remember, we turned our forest cover into an image. And that is very, very important. So we can choose here forest cover call. That's the one that we created, if you remember. And then again here, what we can choose is this number of maximum cells, which is based on this one. Now, for the alpha layer, I'm going to actually increase a bit transparency of this one. So I'm going to use 85% opacity. Then we add the third and the final layer, as we said, and that one is going to be the forest loss or deforestation layer. Now for this one is a pure spatial raster in Terra terms, so we cannot use this one, geospat raster RGB. We're just going to be using the standard one, geospat raster. Okay, so over here, what we want to do, again, we want to define the data, but this time I do want to use here as factor. So I do want to make sure that indeed this is categorical data. I know that in one of the previous steps we did turn it into categorical, but just making sure. And then over here, what we're going to do, pass forest loss region. Again, what you can also define here, as we did before, we want to have, again, the number of cells or a number of maximum cells for this image. I want to be aligned across the board. All right. So once we do this, once we define all the layers here, what we can do is go ahead and define the coordinate reference system of our plot here. It's not really necessary, but just making sure that everything is in the same projection. Okay. And then once we do this, we can go ahead and customize our color palette. Remember, what we want to show here is essentially two values. The forest value denoted with olive green and the deforestation denoted with red color. So for that, because we're working with categorical data, we need to use scale fill manual. So not continuous, but manual. Within this one, you can define, for example, title if you want, which is here denoted by name. I don't need actually title, so I'm just going to leave it empty. You can also define labels. I will define labels. We're going to have actually two labels. The first one is going to be forest cover in 2000. And the second one is going to be forest loss. And forest loss is between 2001 and 2023. So those are the two labels that I'm going to have. Then we can go ahead and add our palette. So our palette is just going to be the pal. And then one thing that is very, very good is to simply get rid of the NA values, so to omit them. And to do that, you need this last line, which is na.translate equals false. So this is then not going to include them into our plot. The final step is to define your theme. So I'm just going to go here for theme void. That's going to be the main one. Theme void simply gets rid of any additional material. And then because I do want to change something about the main theme beyond this one, I will do that here. So for the legend, I want to actually put the legend in that top left corner where there is Atlantic Ocean. So it doesn't really occupy the rest of the map. And then I can actually shrink all the space around the map. In order to put there, what we need is a very small x value of x. So for example, 0.2. And we need a very high value of y because we want to increase the height. Because in this legend position, the first one is the width of the plot and the second one is the height. So that is the first thing that I want to define. And then the second thing, as I mentioned before, I do want to a bit shrink the margins around this plot. So I will be using here plot margin, and then within plot margin, I need to define actually 4 sides of the world. And I'm going to decrease each of those sides, starting with top, going to then bottom side, left hand side, and then concluding with the right hand side. I'm going to decrease everything by the value of 1, and this one is going to be 1 centimeter. The forest loss map of Galicia using olive green to denote forest cover in 2000 and red to denote forest loss from 2001 until 2023. And if you zoom in, you can also see what is the status of deforestation for specific areas or towns. Most of the map, sadly, is in red, denoting a very, very high level of deforestation. And as we saw in our previous analysis, more than a third of the forest cover has been lost so far to deforestation in Galicia. As I promised you at the very beginning, I will also show you how you can create even more breaks. So in the previous attempt, we simply created 2 breaks, whether there is a forest cover and whether there is a deforestation. But what you can also do is you can even create more periods of deforestation. So for example here, what we can do is we can divide these periods into almost 2 equal periods. So what you can do is, for example, include here, if you want, 12. So we will then have actually 3 breaks here, going from 0 to 1, then from 1 to 12, meaning from 2001 to 2012, and then the last one will be from 2012 to 2023. And then the rest here in the step 4, what you can do is simply run, and then you will actually have a new plot, but now this time with actually three values. So once you're done with step 4, then you can go ahead to step 5, which is forest cover. While we are not going to actually touch forest cover here, what we will do is we need to create additional color value in our palettes. And I actually opted here for yellow. Yellow as something like in between maybe the reds and this olive green. So then we will have actually yellow, for example, for this first period. So from 2001 until 2012. And then for the second period from 2012 to 2023, we're going to be using red. And then the very last step is going to step number 8, which is creating the map itself. What you actually want to do here is go to the scale fill manual, and over here we will need to add additional label. So that additional label will be that the forest, we are tracking actually here forest loss from 2001 until 2012, and then here from 2013 until 2023. And as you run that ggplot2 code, you will now see actually 3 color values. Well, the yellow one is a bit unfortunate. We don't completely see it because the background is to some extent beige, but you can actually definitely play with this one. One thing that actually is obvious that there has been quite a higher loss in the last 10 years, denoted here with red. And as you can see, there are even some areas that are pretty huge in the south, and also southwest and west. And that's all for today, folks. You can find the replication files in the description box below, together with some other links that I used in this tutorial. If you have any questions about this tutorial, please leave your comments in the YouTube section. If you are new to R and you seek to expand your GIS and data visualization knowledge in R, I prepared a few cool tutorials for you, so do check them out. See you next time.